For thousands of years, human life followed a steady, familiar rhythm: the rising sun, the turning seasons, and the limits of human muscle, animals, wind, and water. A farmer in 1700 lived much like a farmer in ancient Rome. Every tool was handmade. Every task required effort, and every journey took time. Progress was slow, almost unnoticeable across generations. But beneath this quiet surface, something powerful was beginning to shift. In the damp, coal-rich regions of Britain, a hidden force was waiting to be unlocked. It was not wind or water, but energy stored deep within the earth itself. Coal, later transformed into steam and motion. For centuries it lay unused, silent and powerful. This marked the beginning of a transformation that no one at the time could fully comprehend. A world built on tradition was about to be reshaped by invention, pressure, and discovery. It was the start of a shift from hands to machines, from human strength to mechanical power, from natural limits to seemingly endless energy. And once this change began, it spread across the world, reshaping economies, cities, and human life forever, ushering in an age where nothing would ever remain the same again. By the mid-18th century, one nation stood at the edge of transformation: Britain. Not by chance, but by a rare combination of power, resources, and ambition. Its farms were producing more food than ever before, freeing workers from the land. Its laws protected wealth, encouraging bold risk-takers to invest and expand. And its rivers and coastlines made transport faster and cheaper than most of the world. But the true advantage lay hidden underground: coal. In Britain, it was abundant, cheap, and incredibly powerful. At a time when human labor was expensive, coal offered something revolutionary: energy without limits. This imbalance changed everything. Instead of relying on muscle, inventors began thinking differently. What if machines could do the work of men? What if energy could be controlled? Across the country, mines expanded deeper into the earth, feeding a growing hunger for fuel. And with every ton extracted, the foundation of a new world was being built. A world not powered by nature, but by something far more relentless. When energy becomes unlimited, the first true breakthrough of the Industrial Revolution did not begin with engines. It began with cloth. Across Britain, demand for textiles was exploding. Cotton, once a luxury, was becoming essential. But there was a problem: production was painfully slow. Weaving could now be done faster than ever thanks to new inventions, but spinning could not keep up. This imbalance created a crisis. For every weaver, there were never enough spinners to supply thread. The system was breaking under its own success. Then came a series of inventions that would change everything. In 1733, the flying shuttle doubled the speed of weaving overnight. Suddenly, one worker could do the job of two. But this only made the shortage worse. Soon after, the spinning jenny appeared, allowing a single worker to spin multiple threads at once. For the first time, machines began replacing human limitations. Production accelerated, costs dropped, demand exploded, and quietly inside small homes and workshops, the factory system was being born. When machines make things faster than humans, who survives? The machines were improving, production was rising, but there was still one limitation: power. The spinning jenny was small enough for homes, but new machines were growing larger, heavier, and more demanding. They needed more than human hands. They needed energy. That solution came from water. Inventors began designing machines that could be powered by flowing rivers. Among them was a man who would change everything: Richard Arkwright. His invention, the water frame, was too large for any home. It required constant power, strong structures, and organized labor. So instead of bringing machines to people, he brought people to machines. Arkwright built the first true factories, large buildings, where workers gathered under one roof, operating machines driven by water power. For the first time in history, production was no longer scattered. It was centralized, controlled, scaled. Work was no longer flexible. It followed structure, time, and discipline. The age of the factory had begun. When humans are organized around machines, who is really in control? Water had powered the first factories, but it came with limits. Factories had to be built near rivers. Production depended on seasons, currents, and geography. Industry needed something more powerful, something reliable, something controllable. That solution came from deep underground: coal. As mines expanded, a new problem emerged: water flooding the tunnels. Mines were constantly filling, stopping work and trapping resources below. To solve this, an early machine was introduced: the steam engine. Thomas Newcomen's engine used steam to pump water out of mines. It was large, slow, and inefficient, but it worked. For the first time, Humans were using steam as power. Then came a breakthrough. James Watt realized the engine was wasting energy. By adding a separate condenser, he transformed efficiency completely. Now steam engines could do more than pump water. They could drive machines. Factories no longer needed rivers. They could be built anywhere. Energy was no longer limited by nature. It was controlled by humans. When power becomes limitless, what happens to the world? Steam gave industry power, but power alone was not enough. To build machines, bridges, and infrastructure, the world needed a stronger material. For centuries, iron had been produced using charcoal. But this method was limited by wood, and forests were disappearing fast. Then came a breakthrough. By using coke, a purified form of coal, iron production could be scaled like never before. Furnaces grew larger, hotter, more efficient, and iron began to flow in quantities the world had never seen. This changed everything. Iron was no longer rare. It became the skeleton of a new age. Machines became stronger, structures became larger, possibilities expanded, but this progress came at a cost. Inside the furnaces, workers endured extreme heat, toxic fumes, and brutal labor. Many did not survive long. Still, the industry grew. New techniques like puddling and rolling transformed raw iron into usable forms faster and cheaper than ever before. The machine age was no longer an idea. It was being built, piece by piece, in fire and metal. The world was rising in iron, but at what human cost? As factories multiplied, something even greater began to change: the movement of people. For thousands of years, humans had lived close to the land, but now they were leaving it behind. Driven by lost farmland and drawn by the promise of wages, millions began migrating into growing industrial towns. Cities like Manchester expanded at an unimaginable speed. Small towns became crowded centers of industry almost overnight, but this growth came without planning. Housing could not keep up. Families were packed into narrow, dirty spaces with no sanitation. The air thickened with coal smoke. Rivers turned dark with waste. Clean water became rare, and disease spread quickly. Cholera, typhoid, death became part of daily life. Inside the factories, conditions were no better. Long hours, low wages, and constant exhaustion defined existence. And yet people kept coming, because despite the suffering, this new world offered something the old one could not: opportunity. The cities were growing fast, but were they built for life or survival? By the early 19th century, the factory system had taken firm root. First in Great Britain, and soon spreading to the United States. But behind the rising industries stood a harsh reality. Factories demanded discipline. Work no longer followed the sun, but the clock. Shifts stretched for 12 to 14 hours a day, 6 days a week, and many of those workers were children in the mills of England and the growing factories of America. Young boys and girls labored in dangerous conditions, cleaning machines, fixing threads, crawling beneath moving parts. They were cheap, replaceable, invisible. At the same time, adult workers faced strict rules, low wages, and constant pressure to keep up with machines. But resistance began to grow. Workers started organizing, speaking out, demanding better conditions, shorter hours, and fair pay. The first factory laws were introduced, limiting child labor and bringing small reforms. It was slow, difficult, often resisted. But something had changed. For the first time, workers were no longer silent. When machines control work, who fights for the humans? By the mid-19th century, the Industrial Revolution was no longer confined to Britain. It was spreading across Europe, across the Atlantic, and beyond. But this expansion needed one thing above all: movement. Factories were producing more than ever before. Coal, iron, textiles, all needed to travel faster and farther. The answer came in the form of iron rails and steam power: the railway. In Britain, the first major lines connected industrial cities like Liverpool and Manchester. For the first time, goods and people could move at unprecedented speeds. What once took days now took hours. Soon, railways spread across Europe. In Germany, they helped unify distant regions into a single industrial force. Across the Atlantic, the United States embraced mass production, building vast rail networks that stretched across the land. And in the East, Japan began its rapid transformation, adopting Western technology to build its own modern industries. The world was no longer distant, it was connected. When distance disappears, how does the world change? By the late 19th century, the first industrial revolution had transformed the world. But a second wave was already rising. This time it would not be driven by steam and iron alone, but by steel, electricity, and new forms of energy. The invention of the Bessemer process made steel stronger, cheaper, and widely available. Cities began to rise higher. Structures grew taller and more ambitious. Electricity followed, bringing light into darkness. Factories no longer depended on daylight. Work could continue without pause. New industries emerged. Chemicals, engineering, and mass production reshaped economies. In the United States, assembly systems began producing goods at unprecedented scale. The world was becoming faster, more connected, more powerful. But the cost remained. Pollution darkened skies. Industrial growth widened the gap between rich and poor. And yet humanity had crossed a point of no return. The modern world had been built. From the first spark of coal to the endless hum of machines, this was more than a revolution. It was a transformation of human existence itself. The question is no longer how it began, but where it will take us next.